Okay, kids, we're gonna try something a little bit different today. Don't you love when people say that, like they're actually gonna do something? I'm not actually gonna do anything. I'm lying. Um, so this fella I know writes me up, says, "Hey, can you make a synthesizer for $10?" And I'm thinking, I don't know. It sounds cheap to me. However, I thought about it some more and I had some ideas, and this was my idea for a sort of rudimentary theremin type deal. I drew this from memory, so I thought that it would be interesting to try to just do this without any real setup and previous whateverness to give people an idea about what it might look like. Um, this is a 4046 chip, which you probably can't read the little tiny numbers on there. It's a 16 pin dip. These are about $1. Has a big notch here on one end, and that indicates the number 1 pin is the one here. So I'm going to stick this in the breadboard, and that's the number 1 pin there, and then they're numbered counterclockwise around. So then put some wires in here to get this to maybe go and see what happens. Kind of fun. Okay, the power comes in at 16. It also has a little rectifying diode in there to stabilize the power on pin 15. So putting both pins 15 and 16 to high, which is going to be 5 volts here eventually. The low is standard position here at pin 8, so plug that in there. So far so good. I believe that this chip is, the inhibit is on 5, pin 5, 1 2 3 4 5, and I believe the inhibit is active low, or I'm sorry, active high, which means that the chip is inhibited when it's high. So I'm going to ground that pin as well and see whether or not that's true. It might be that I have to run that pin high if it doesn't do anything. It also might not do anything because I'm doing it wrong. All right, the base oscillation for this is a VCO chip. I'm just using the VCO on it. Is controlled through a resistor and a capacitor. I'm using a 104, which is a 0.1 microfarad capacitor, and pins 6 and 7 for the capacitor. The output is at pin 4. I have here my a 2.5 watt amplifier, a little deal here hooked up to a speaker that's separately powered. That comes out at pin 4. So that's going to be my input to the amplifier, and then this is my ground to the amplifier. I'm going to stick that in the ground here. So that's where the amplifier is going to go. I need a DC blocking capacitor for the amplifier. I wrote down 4.7 microfarad capacitor for that. Don't have here. Oh, I guess I do have one of those handy. But I don't think the value of this is very critical. I think we could probably use something much smaller, say 1 microfarad, or maybe even just another one of these, 0.1. I'm going to use the 4.7 here. So from pin 4, out to my, see if I can get the little leads there to cooperate. There. The positive side goes toward the chip, the negative side is headed out to the amplifier. Alright, so that's hooked up. The other thing that I need is the resistor to set the bass oscillation of the VCO, and I'm using, grab the wrong one here, 47K. Usually I put that on a potentiometer so I can vary it, and I'm not doing that. So that's going to go in pin 11, 8, 9, 10, 11, and that goes to ground. This is a minute. There we go. So 47K there to ground. Unify my grounds here across the top of the breadboard. Okay, so that's basically it. That's all I'm doing. And then I need an antenna. I'm just going to use a wire here and poke that in pin 9. There we go. Pin 9 provides the input to the VCO, and there we go. So this is the circuit I'm going to try to test, see what we got. Now, I've left some stuff out, and I'm just trying it to see what I get. So now I need power. I suggested just using standard, some sort of, not the most eloquent guy, am I? This is a Cupertino power supply for charging stuff through USB. I was just gonna use that for a power supply because they're ubiquitous. Everybody has them, and everybody has the 5 USB cable to some kind of output, and I don't care about that, so cut that off. I'm just using it for power. I don't care about the data lines. Where's my wire strippers? So see, this is where you really spend all your time, is looking for the tools. I should say where I spend all my time. Okay, so I'll strip this off. There's nice ground. That's pretty clear. And then I'm expecting to see 4 wires in this mess, in addition to the grounding area here. I'm going to peel this open. I love when people say doing something different, because none of it's different. It's all just a YouTube video. That's a nice little shroud there, but I kind of feel like that's in my way, so I'm going to cut that off. Okay, so there's 4 wires, as I'd anticipated, and a little piece of something to make it more bendy, probably. Red, black, white, and green. I'm guessing, perhaps incorrectly, that the power is coming out through red and black. Now, I could just try it, see what happens. It's not a completely inappropriate choice. However, for the sake of my own edification, I'm going to go ahead and plug this in and see if this is indeed the correct thing. I have a meter here. I'll set this to 20 volts and see what I got squirting out of here, just to make sure. 0 volts. Well, that doesn't seem right, does it? What if I use this ground? Oh, my power strip's not on. Maybe I'll turn that on. Okay, let's see what I get now. Whoop! There we go. Let's short that out so that we know that we blow up the power supply so that we can find another one. I say we, but I mean I, because you're not actually here. Good heavens. Okay. Stay as if it's a dog. I'm trying to do this relatively quickly to so that it's not too boring to watch. Fiddling around with these things. All right, let's see what I got now. Hey, look at that, 5.09 volts, solid 5 volt there. Red is high, black is not. Oops, dropped it again. Turn off the power strip so that I don't short anything out. So there we go. That's my power supply. Red and black, black being the ground. This is also a ground, and could sister these together. So let's see here. Yeah, put the black here in the negative rail. That doesn't hold tightly at all. All right, well, it's going to require some additional dorking around. Turn on the soldering iron here and wait for that to wake up. This is the idea here is a sort of rudimentary theremin. I should have something entertaining to say at this point. Typically at the output here we would have a resistor, maybe adjust the volume. I'm adjusting the volume on the amplifier, and I wanted to keep this as simple as possible. Also to keep the cost down. So there's also no bypass capacitance here. Okie dokie. So the soldering iron's hot. Solder is available. See the smoke. It's a good sign. Tin these wires up here, and it'll make it a little stiffer and maybe make it grab a little better in the board. Oh, well, that's way too big. That's never going to go in that hole. Alrighty then, let's see if I can get these to poke on in here. Ground in the ground. Almost. High, no. Ground in the ground. To reiterate. Yep, not going. So we go from too loose to indescribably tight. Just like that. Trying one more time. Alright, not gonna work. So, more than one ways to skin a cat. If that's a thing that people say, isn't it? Okay, there's my power. There's my ground. Go to jumper land. I'm going to use the yellow one here for the power. And use the black for the ground. To the blue wire, just to make it confusing. Ta-da. Okay, so now I should have the power supply hooked up. This keeps wandering around. Put that hold that there on the desk a little bit, maybe? Something, please? Anything? Okay. Let's check and see what this looks like. Oh, it looks like I'm doing something. In the wrong direction even. Okay. So flip the thing on the power supply on here. So now this is getting 5 volt. And then we'll turn on the amplifier. There's a lot of buzz there. It's definitely making noise. Okay, well, it kind of works. I'd like a little bit more variation in the pitch with that. So, and it does seem like I'm getting a lot of interference, so maybe a little bypass capacitance is a worthwhile addition. So between, unless it's off, because it's being held. So I'm going to put some bypass here in between the high and the ground. See if that sounds any better. Not really. It didn't make any difference, so heck with that. Let's try a smaller resistor in here than the 47K. I'm going to try 22K and get the pitch up a little bit here. And this is from 11, pin 11 to ground. It's also possible that I've screwed something else up. Oh, good heavens. 9, 10, 11. I also am doing this from memory. Usually I look at pinouts and data sheets and make sure I'm hooking stuff up right. Today's a special day. Okay, let's see what that sounds like. Sounds pretty much the same. Let's stick this in high, the inhibit line, high. See if that makes any difference. Nope. Well, yeah, now it's not working. So the inhibit's definitely... The inhibit definitely goes low. I have a ton of line noise on this. Maybe I shouldn't have cut off that little bumpy thing there. Maybe I need to connect the other ground. Maybe lots of things. All right, well, so it kind of works, kind of doesn't. Let's try to smooth out the power going in just in case I'm getting a lot of noise on the line, and that's one of the things going on there. So bypass this with I think I grabbed a 10 microfarad capacitor. The negative side goes to the ground. That's the striped side. Let's see if that sounds different. Nope. Still not getting it. Fun. All right, so let's take a look at the other ground here. Maybe the shielding ground is not shielding, and that's why there's all that extra noise. Stick those two together. Okay, that's hot. All right, so now I have the shielded ground connected to the ground. And the black wire goes to this. Let's see what I have now. None of that's making any difference. This didn't even feel like it was in. That just popped right out. I don't think that's going to make any difference. I want to try that other resistor there. 100K from the output to ground. Add some impedance here, see if that cleans it up. Well, it's working. I just don't know where that huge buzz is coming from. Maybe it's the cable, maybe it's that I'm using the wrong deals here. So, how much troubleshooting does anybody want to watch? I don't know. I guess I can always cut it off, right? If somebody says, hey, that's too long and boring. Okay. So what I used 4.7 here, as I recall. Yes, let's lower that to 1. That might act more as a high pass filter. Let's see, 4 out. Okay, that'll sound the same. Yeah, okay. It does show us that it doesn't seem to, that it's not super critical. Looks like all my wires are in the right place. So the next thing I do is I'm going to try a different power supply to see if it's just that the power supply is super dirty and I'm not getting what I want out of that. So we have my desktop power supply here. Gonna hook that up. We'll turn off the other one. Hook up the ground. I don't have anything running high over here, so okay. And the high is here. Something red would be pleasant. Wow, that's loose. That's loose. That's loose. There, that seems pretty good. Connected up. Now I'll try it with this power supply. So if I run my antenna here to ground, it shuts off the oscillator. If I run it high, it'll be at its highest pitch. When it's floating, it's somewhere in between. This would be a static sensitive deal, so probably want to be a little bit careful about that. It's basically operating the way that I would anticipate. I can change the base pitch that it oscillates around by changing this resistor. That's pretty good though. It's about what I would like. Now, I want to... Oh, right. I was... by using me as a giant 3 meg resistor between ground and high, I can ground the oscillator or run it to its high point without doing that. So pretty responsive, pretty good. So the problem is with the power supply being super dirty and making all that background noise. So maybe this isn't the best choice for a power supply. Could probably use a 9-volt battery. That might change the component value of your resistor. And this doesn't make any difference to speak of that I know of. So yeah, pretty nice. 4 components, 1, 2, 3, 4 components, the IC there, a few wires and a power supply, good to go. Maybe I'll try to figure out why this power supply is doing that. Maybe the white wire is not a data wire and is the power wire, or something else. I don't know. This seems right to me, but for some reason this is super dirty. It could be that the cable is the problem. I'm not sure. Anyway, proof of concept. There's your under $10 theremin there. It's about $2 maybe, not counting the power supply, which evidently might be a problem. So maybe I'll check into that. Good enough for today. Have a great rest of your afternoon, and I hope you watch a lot of YouTube videos and they're not as interesting as this.